All right. I don't know if you can see it. NET-113. This is it. Last day in November. So we are on week 14, and this was Thursday. And here we go. First of all, this little diagram, we talked about compression of files. I'm talking about networking and the presentation layer where you can compress the data, format the data, and encrypt the data. So we talked about, let's say, all of this is like green grass or something, okay? And when you compress a file, since you have lots of bits representing the same color, you can say we have, these bits, and we have 5,000 of them. So we can really compress it, because then when we decompress it, we can take those 3 bits and decompress 5,000 of them. So you can represent a large part of the document, picture, whatever the document is, or whatever it is, by looking for repetitive sections in there. And that's one way to compress. There's lots of algorithms, but at least hopefully that gives you an idea. Okay, so we did a lot of work today on networks, and this is not in necessarily the order that we covered the material, but that will be irrelevant. I'm just going to cover the information that we had on the whiteboard. Documenting a network is crucial. We didn't do much with that today, but we'll talk more about that as we move along, finish up the year, and we'll talk about it in networking classes in the future. Okay. Cable, we talked about cabling today. Cat3, not used much anymore. Cat5 and 5E, really popular. Most people are going to Cat6 when they put in new. There are other levels out there. The important thing is that you understand there's different categories, and we're talking about twisted pair. Okay, it's very important here. We're talking about twisted pairs. More about that here in a minute. Okay, so we talked about different types of cabling. They looked up some prices. We plenum cable we can put up above in the plenum where the air is. That's special cable that when it burns it doesn't leave off a toxic chemical. We talked about riser cables that have a thread in them, like here, an extra thread, so when you put a cable in a long run up and down, the weight of the cable doesn't damage the twist in the cable. More on that in a minute. Cable that's fire rated, so when it burns, it doesn't burn as well as just regular old cable that's normal cable that's not set for fire rated. And there's some big issues. If you have like a big cable run in a building with lots of cables and a fire breaks out on this floor, that fire can move down and then come out, break out on another floor, and it just follows the cable run down. Alright, let's go to the next page there. So, big items in cabling. We talked about the way you wire cable. We talked about the 2 different methods, 568B. That's the one that's most popular. There's also 568A. And then we talk about how you design a physical plant, 568C. And we'll go through that more in a little bit. Now, we did talk a little bit about fiber and Wi-Fi, but today we were emphasizing twisted pair to understand that in terms of wiring a business or building or commercial building or whatever. Distance is crucial. You can't go over 100 meters total, and we have a breakdown of that coming up. Crosstalk, at the end of the cables, when you put the end on, it's very important not to lose the twist in the cables, okay? Not that straight wires. Straight wire, you have the right-hand rule, so if electricity is going this way, you get magnetic field going that way. When you put straight cables next to each other, those magnetic fields interfere with each other. Get all this interference right in there. So what they do is they twist the cables. Some of the twists are more gradual, some of the twists are way more tight, and so forth. So we have 8 cables, 8 wires right here, and they're all twisted differently. Okay? So we have 1 and 2, pins 1 and 2 send, 3 and 6 are receive, and then depending on 568B, which colors you have where. Okay? So it's very important to keep as many twists. The same thing when you punch down into the RJ45 jacks or into the patch panel. The ends of the cable. Alright? And we'll keep moving material, so I don't want to get this to be too long. So we talked about in a facility you have horizontal runs. And these are like, they call these horizontal cross connects. Intermediate cross connects and main cross connect. So we used our room as an example. Horizontal is like where the devices are. You have maybe a jack hooked up in the wall, and that has a patch panel connects to your computer. Here is your horizontal run to a patch panel, and that patch panel then connects to a switch. So in that scenario is what we can talk about. This cabling shouldn't be over 90 meters, and your patch cables on each end shouldn't be over 5 meters. Okay? Now a horizontal run is the run from your cross connect to your devices. And we're talking about cabling now, we're not talking about wireless. Vertical runs, they are between devices. Same rules apply, 5 meters, 5 meters, 90 meters, so it's never over 100 total on cable, twisted cable. But these are your vertical runs, like when you leave here, I'm down here in the diagram, and you're running your cable from this horizontal cross connect to this intermediate cross connect, and then from that one to the main cross connect, and then the main cross connect to your POP. Point of presence or demarc, sometimes called an entrance facility. This would be, for example, the connection to your ISP or to another network or whatever. That makes sense? So this is going out of your facility. So they call that the point of presence. Typically where your phone lines come in if you're still using phones. So vertical moves up in this hierarchy. Horizontal cross connect connects all the devices in that particular area. Okay? Now, if you have a wiring closet, and you have a wiring closet here with an intermediate cross connect, also in that wiring closet, you could have a horizontal connect that connects devices too, but it really would be thought of differently. Not the same, even though they could be in the same room. All right. So I gave an example up here where we talked about, I'm going to let you think about that for a second, okay? A couple other terms. Main distribution facility or main distribution frame, intermediate distribution facility or intermediate distribution frame. These are a little bit older terms. Okay, the cross connect is what we use nowadays. All right. So this standard talks about these items that we talked about right here. Now, here's some I didn't mention yet. Power supply. Power supplies. You can have a building, and if you're connecting, let's say, 2 buildings, and they have different power supplies, they have a different potential. And with a different ground potential, you can develop a circuit between the 2 buildings. So, if you have different power supplies, you want to run fiber in between them. Also, if you have too long of a distance to go, you'll probably have to run fiber. Okay. Or if you have to go outside between buildings, you want to run fiber to avoid lightning strikes to your cable, even if your cable's in the ground. So example at Newman, the high school and the elementary, this was a long distance, so we put fiber in, plus the elementary had a new power supply coming off this direction. High school's power came from this direction. There were two separate power supplies, so there was a ground potential difference here compared to here. So that's another reason we had to use fiber to connect those two. I'll keep moving. Alright, here's where we actually started out today. We talked about the layers again. We started out talking about the physical layer, and today we talked about wire, how important twisted pairs are. And if you look in a Cat5 5E cable, that's what we have in the classroom, you'll see those 8 wires, and the twists are all different between them. Okay, the twist between the color and the white, color and the white, color and white, color and white. Okay, coaxial cables still used a lot. Cable modems or cable television and so forth in the house, but rather than put in new coax, they should just put in fiber from here on. Wi-Fi is good, but it has its drawbacks too. So we talked about the hierarchy then. Access to the network, best path, how you're going to transport the information, set up a session, and then we talked about those 3 things at the presentation layer. Format the data, compress the data, encrypt the data, and then your link into your application. Some network terminology. Sometimes PAN is used for a network close proximity of your devices, Bluetooth and so forth. Local area network, we talked a lot about those in the networking class, where same geographical area under the same control of the network administrator and so forth. Wireless LAN, using access points and connecting. Metropolitan area network, by the way, that's personal. Metropolitan area network, we have gave an example here in Mason City, where they have fiber connecting the fire station, the library, the police station, Mohawk Square, City Hall, county, and then back here. And I'm not sure this is the exact loop, but they have that. And just think, that could be powered by uninterrupted power supply. So we could have a major, disaster, tornado or something, but a lot of that would still function. That's in the ground, it's fiber, they all connect. And we talked about they either connect right now, I'm pretty sure they connect by routers, but there could be other ways to do that, and that's all fiber. So that would be a metropolitan. And then we talked about WANs, using a service provider to connect your 2 networks. Okay? Pay somebody. Another way to have what would be a simulated WAN too, you also can use short haul microwave and send the signal through the air. And we gave the example of Curry's. They have a place on 9th Street and then out on 12th Street. They used to, I don't know if they still do, they used to connect by short haul microwave. They had a tower on each location and they had line of sight between those. I better keep 2 more pages, believe it or not. 6 and 7. Alright, so here we talked about the internet. And the internet, some people will call that a large WAN. It really isn't. The internet itself is an infrastructure that allows us to create a WAN. It is not a WAN within itself. That's getting a little technical, but it really isn't. So a lot of locations, rather than paying a provider to connect your 2 locations, if you trust sending the information through the internet, you can just connect the 2 ISPs and then create a VPN, virtual private network, in which uses for an example, IPsec on both ends, IP secure. It encrypts the information, sends it through the network, and decrypts it on the other end. All right. We talked about the things you measure, bandwidth, bits per second, based on time. You can measure how much data you're pushing through, and then they talk about data throughput. Even though you might have a 100 million bit per second connection, that doesn't mean you're going to get that much data through, because we have lots of overhead. We have overhead in the packages, and we have latency in the time it takes the devices to switch the data from one network to another. Even though that has improved tremendously over time, there is still some. So your data throughput is how much actual data you get through. Okay? Connections, we talked about cellular. I'm not going to repeat that. Wireless, you can connect by satellite, cable modem, DSL to connect into the internet, get it filtered. Synchronous DSL, same amount of data up and down, but you need a separate phone line for that. Asynchronous, you have a lot down and a little up, and that you can use a filter and run your phone and your device at the same time. We did talk about the old modems and dials ups, plain old telephone service, and I talked a little bit about how that would work. How that works. For example, you could have that with your network equipment and use the phone system to log into your network equipment if all other items were down. Okay. I talked a little bit about telephone company and the wires, copper wires. They run out all the way to the location, like to your house, runs all the way back to the telco. All right, so one page left. So I already talked about this. This is just a little review of devices. You don't see them much anymore. You might run into a hub somewhere. So remember, a hub, when one device sends information in to go to another device, it gets broadcasted. It goes out everywhere. So anybody else on the device at that time will see that traffic, even though it's not meant for them. Sometimes on older switches, you can fill the buffer and then they start acting like a hub, which is a security issue. I think newer managed switches wouldn't do that, but I'd have to do a little research on that. But a switch, keeps track of the MAC addresses and only sends the information to the right location. And we have routers that route between networks. And then we talked about these multi-layer switch, where you have a router switch. And these little routers at home, or small business, they can be all those things in one. Or in your home, you could get, let's say you have MediaCom, you could have a cable modem, you could have a little separate router, and then you could have a managed switch, and you could have an access point. You could buy those all separate too. Alright, so to summarize today, we did a lot of work from chapter 9 in the text, which talks about a lot of the physical connections, the wiring and so forth. And we did some wire work in class. They did some wiring, they did some punch downs. And that stuff's all available all next week for students to practice doing that. And we also looked at that 568C, which has the recommendations for the standards. The standards in wiring a commercial building. And we talked about that main cross connect, intermediate cross connect, and horizontal cross connect. All right, that's it for today.